Math. Hey there, we're back with lesson 2.2. Now we're going to focus on least common multiple. So we're going to be able to find the least common multiple in various ways. And we should explain why a certain number is the least common multiple for two given numbers. Okay, so again, I have my little warning in the corner reminding you that there are different ways to find GCF and LCM. But if you truly understand what they mean, then any method will work for you, and you can use any method, okay? So the first one we're going to look at is not one that I would use very often, but it is one that kind of helps us explain what least common multiple is, so I do like to go over it, and it is best used with those really small numbers, okay? So best used with real small numbers. You guys are always welcome to use this. But like I said, this probably wouldn't be my go-to for most things unless I really struggled with my multiplication facts. Okay, so what we're going to do for the number line method, is we're going to be marking off the multiples for the first number, okay? So we're marking off the multiples of the first number, and we're going to be marking off the multiples of the second number on our number line. And then we are just going to look at where the two numbers are in common and which one is the smallest. Which one is the smallest numbers in common. Super simple, okay? So we're going to do the first one in yellow. So 2 is going to be our first number. And I'm basically just skip counting by 2, okay? When we skip count, we don't start with 0. We start with 2, right? We don't go 0, 2. We just start with 2. So we're going to go 2, 4, 6, 8, 10, 12, 14. Then I'm going to take my second color here and I'm going to skip count by 3s this time. Again, I'm not starting at 0. I'm going to go 3, 6, 9, 12, and those are all my 3s so far. Okay, I am now looking specifically at where these are in common, right? Where do I have 2 of the same multiples or 2 of the same dots? And I am looking for the smallest one. Okay, so in this case, 6 is the smallest common multiple of 2 and 3. So you can probably see why we use this with smaller numbers, because if you're doing this with 56 and 30, you're going to be skip counting to really big numbers, and you don't really want to make a number line that big. It just takes a lot of time. You can, but it takes a lot of time. So I'm going to show you some better ways to do it, but using our number line is a good option. Okay, here's a nice visual for you too if you want to do it with X's. Okay, so the next way that I'm going to teach you is just a list method. And this is the good old tried and true way that your parents are probably sitting there going, hey, this is the way that I did it when I was in school. Well, they're right. This is the way we did it. So for this, we're still using 2 and 3. I was going to do 2 different colors. Let's try that again. 2 and 3. But we're not going to be skip counting on a number line. We are just going to list the multiples of both of these numbers. We're just basically skip counting. So again, listing multiples is skip counting. Okay, and sometimes you don't know how to skip count by a certain number. You don't have it memorized, but that's basically what we're doing, and we are going to stop when we find the first one that they have in common, basically that smallest one they have in common. Okay, so I'm going to skip count by 2s. 2, 4, 6, 8, 10. Go ahead and do, 4 to 5 numbers and then switch to your other number, because especially these are little numbers, we should know what they have in common. But if I am skip counting really big numbers, I might not know what they have in common. So you kind of want to just go back and forth between them until you get one they have in common. So 3, 6, oh, there we go. That's the number they have in common right there, 6. Okay, so I know that the LCM of 2 and 3 is 6. So this is going to be the one that you'll probably use the most often, especially with those smaller, friendlier numbers. probably under 12-ish, maybe, friendly numbers that are in the tens. But you're going to probably use this one more often, listing the multiples. All right, and the last way I'm going to show you is back to that prime factorization method. Again, this works really big when you have really large numbers, because again, I don't want to skip count by 112 and 36. That's going to take me too long. I don't know those off the top of my head, but I could easily break it apart into prime factors and then use my Venn diagram. Okay, so that's what we're going to do is do prime factorization for this method. And like I said, it's really good with those big numbers. So same thing as before, we're going to get all of those prime factors by using a factor tree. Then we're going to put them in a Venn diagram, and then we're going to multiply basically the common and uncommon factors. And I'll show you what that means, but we're basically going to multiply any number we put in our Venn diagram. Okay. So for 8, let's do 2 and 4, 2 and 2. So prime factorization for 8 is 2 times 2 times 2. Then I'm going to do it again for 12. We're going to do 2 times 6, and I'm going to break this apart into 2 and 3. So for 12, I'm going to have 2 times 2 times 3. Okay. Now this time I'm still sorting them in my Venn diagram, okay? But I am going to focus on those numbers they have in common again. So I'm looking for the numbers in common. So they have 2 sets of 2, and that's going to go in the middle. And then any number that's left over for 8 goes over here. And any number that's left over for 12 goes over here. And now, with our GCF, we multiply just the middle, but for LCM, we're going to multiply all of these numbers in this Venn diagram right here. So I am going to multiply 2 times the 2 2's in the middle times that 1 2 on the end. And when I multiply all this out, it's going to get me my LCM. So 2 times 2 is 4. 4 times 2 is 8. So that's 24. So the LCM of 8 and 12 is 24. And that's how you do it with prime factorization. So the difference between LCM and GCF for prime factorization is GCF is just in the middle here, and LCM is all of the numbers in the Venn diagram. Okay. I'm going to show you this just in case that kind of lays it out clearer for you. Here they multiplied it a little differently. Okay, just like last time, we're going to take a pause, and I want you to use any method that you want to find the LCM of these numbers. Oops, I forgot this needs to change. Hold on, let me fix it. Okay, use these numbers right here and do all 3 of those. And then come on back and see if you got them right. So you can make number lines, you can do the listing method, or you can make prime factor trees. Okay, so I tried to use all 3 ways for you. So here I found the LCM of 60 by doing a number line. So again, this kind of shows why I would not want to use a number line for the most part, because I'd have to make this giant number line. Luckily, I just took one off the internet to figure out, and then I highlighted the spots where I skip counted and found the one that they have in common, the smallest one. You could also do any of the other 2 ways for those 2 numbers. For number 2, I chose to do prime factorization tree, and ironically, both of these are prime, so they only have the factors of one of themselves, and so I just multiplied those together, and that is a fact that we need to remember, that if you have 2 prime numbers, you just multiply them together. Okay, you don't need to list their factors and skip count, and you don't even need to go by number line. You just multiply the 2 numbers together, because that's going to make your smallest, least your smallest common multiple. Okay, and then on the last one here, I went just and listed them. I listed my multiples of 6 and 10 and found that 30 is the smallest one they have in common. Okay. So on the next way that we're going to look at is another word problem. word problem. So in this case, a store is holding a promotion. Every third customer receives a free keychain, and every fourth customer receives a free magnet. Which customer will be the first to receive both a keychain and a magnet? So you can almost think in your head, if I'm skip counting and counting every third customer, and I'm skip counting and counting every fourth customer, when the two meet up, that would be the least common multiple. So I'm basically going to find the least common multiple of 3 and 4, and that's going to be my answer. Okay, so I'm just going to use the listing method because it's small enough and I don't feel like making a number line right now. So I'm going to skip count by threes: 3, 6, 9, 12, 15, 18, and then I'm going to skip count by fours: 4, 8, 12, 16. Oh, look, I already have one in common: 12 and 12. So the 12th customer will be the first one to receive both a keychain and a magnet. And it's that simple. So down here we have another one that's pretty similar. Whoopsie, if I can get to it. All right, so during February, Kevin will water his ivy every 3rd day and his cactus every 5th day. On which day will Kevin first water both plants together? And will Kevin water both plants together again in February, if February has 28 days? So go ahead and try this one on your own, similar to the one we just did here. Okay, and find the LCM and see if you can answer the second part as well. And then join us again and see if you're right. All right, so hopefully you figured out that Kevin is going to water both of his plants on day 15. And I ended up reminding myself that 3 and 5 are prime, and we just said earlier that if both numbers are prime, you just multiply them together. So I did 3 times 5. If you skip counted by 3s and skip counted by 5s, you also would have gotten 15. Okay, so 15 days. And then to answer the second part, no, Kevin will not water both plants together in February, because if he's watering them every 15 days, the next time they're going to get together is going to be 30. And there is no 30 days in February. So he's going to water them again in, March. Yeah. Okay. All right. Keep practicing and working hard, and let me know if you have any questions. Bye.